Canada has become a global leader in quantum computing research, and our investment in it is about to explode over the coming years. Here to discuss this cutting-edge technology, its implications, and the challenges we face bringing it to market, please welcome President and CEO of the Ontario Centre of Innovation, Claudia Krywiak, and founder and CEO of Xanadu, Christian Weedbrook. A big round of applause.
Good afternoon, everyone, and thank you for joining us today. So for many years now, we've heard the narrative that quantum computers are going to be transformative and breathtaking in terms of the impact that they're going to have. We're going to be able to do computation that now takes us months, years, or even decades, and we would be able to do that in mere seconds. We're here with Christian to kind of unpack that and to talk about what strides we've made, where we're going, and what the future might look like with respect to quantum computing. So let's dig in, and why don't we start? So Christian, what are some of the most exciting recent advancements in quantum computing, and how is Xanadu contributing to these developments?
Yeah, thanks Claudia. And the biggest thing is quantum computers exist today. Xanadu has them, and so do others around the world, but they're not big enough. So they actually need to be something like a data center size. So the goal for us and others to build a quantum data center. And this data center would be on an acre or two of land, and we'd be populated with hundreds or thousands of server racks that have small quantum computers in them. And they're all networked together, essentially talking to each other. So scalability and through networking, and also the ability to make sure that the answer is what you want, are two of the biggest issues. And we've seen, particularly the last 6 months, a lot of breakthroughs when it comes to error correction. So this is the making sure it gives you the answer that you want when it's at a large scale. So a lot of teams around the world are working on that, so is Xanadu. And I would say we'll be announcing in the next couple of months a big breakthrough when it comes to the networking side of things, which has always been a thorn in the side of every quantum computing company. But really they're the big ones. That's from a hardware point of view. And from an algorithms point of view, a lot of work is on what are we going to do with these quantum data centers once we have them. You mentioned the speed ups that are possible. It's definitely true. Not for all problems, but for a subset of very important problems is the hope.
So can you provide us with some examples of real-world problems that Xanadu's quantum solutions are addressing or could have the potential to address?
Yeah, so we demonstrated quantum supremacy 2 years ago, and that wasn't for a practical problem, but for an esoteric math problem. But it was an important stepping stone. And for that particular math problem, we went head-to-head against our quantum computer that we call Borealis, against, at the time, the world's fastest supercomputer. It would have taken the world's fastest supercomputer 7 million years to solve this problem. And so it's still running as we speak. But for us, we solved it in 2 minutes. And now to your point, it's how do we choose specific problems that we can see some of these benefits. And usually at an industry overall, you hear about logistical problems, financial problems, drug discovery, and material design, say quantum chemistry. Particularly material design and quantum chemistry, these are things that, we have drugs, we have new materials, and often the products from them come from computer simulations. These simulations are approximate because you're not using quantum computers, you're using traditional computers. So the idea is to use a quantum computer to simulate drugs, drug interactions, new materials, and give new candidates for drugs and also materials. That would otherwise, to get the right candidates, would have taken years to do. And for instance, drug discovery is famous because it takes 10 years, on average 10 years, $1 to $2 billion, and still 90% of the candidates fail after all that. So we hope, and others in the industry hope to flip that, so 90% success rate. What we're working on, given that's kind of the ecosystem, is next generation battery development. So we work with all the major car companies and also get investments from some as well in our last round, with the premise that once you have this large quantum data center, how does, say, Volkswagen or someone uses computational power to develop new candidates that can then lead to batteries that are 10 times, on a single charge, 10 times longer range, 10 times faster to charge for that single charge, and also while maintaining the stability and safety of these batteries. So that's kind of the wonderful, applications of quantum computing.
How far away do you think such applications are?
Well, the good thing is all these companies are working on them now, but we don't see any speed ups. That's important work to continue last few years and the continuing next couple of years. The end goal is this data center. That's when you can start solving these problems. We anticipate around 2029 to have this data center, so it's getting closer and closer. If you look at our hardware roadmap and achievements, we've pretty much hit all of our milestones that we said we would. There's been some delays, but for the most part. So we feel confident, but when we're interviewed and also when we talk to investors, we always say that's a stretch goal. Things need to go to plan. But 2029 is what we're aiming for, and it could be a little bit longer, a little bit shorter if things go even better. But that's what we're aiming for, and to do it in Canada as well, in Toronto.
So when we first met you, Christian, at the Ontario Centre of Innovation at OCI, was back in 2016, 2017. You had just finished your postdoc at the University of Toronto, and you were embarking on the commercialization journey, trying to take the research that you had done out of the research lab and bring it into the marketplace with starting up Xanadu. Can you talk a little bit about the challenges that someone faces in trying to commercialize an advanced technology like that, and then also how organizations like OCI and others helped you along down that commercialization path, especially at the early stages?
Well, it's very tough, and the tough thing is for something that's kind of deep tech like quantum computing is funding. You need to hire, the first 70 to 100 hires are all PhDs, and so that takes a lot of money to do that, along with all the hardware requirements. One of the challenges that I had in the very, very early days, say the first year, is obviously raising money. But the lack of even small amounts, say 20K, to help me survive and pay my rent while I'm trying to raise, say, first round was $2 million. And that's where OCI came in and provided a lifeline of that amount that's, not enough to go years without funding, but enough to keep, say, in my case, a founder paying the rent and surviving while still working on something important. So, initiatives like OCI are key for the past and the future for entrepreneurs, particularly in deep tech. And in terms of the first part, taking it from academia, it felt very natural for me because when I was a kid, and to this day, I've been reading books on entrepreneurs was excited and motivated by them. So I was always waiting and hoping. I didn't know if it would happen, but if there was this collision of my interest as an entrepreneur, interest in a PhD that I did in physics, and there was, and so far so good. We don't know how this is going to end, but the promise of quantum computing is well worth any probability of failure. And I think because quantum computing came from academia, it really helped that for me managing up to 100 PhD students. It was more natural for me to do that because I was kind of one of them. I know there's other stories where it's hard to manage PhD students, but I think that gave me a leg up. But the overall theme, I think, is the support of very early stage entrepreneurs. But for things that don't look like they're going to pan out, or if someone was certain there was going to be a quantum computer, the applications. I mentioned some key applications, but I think even more will be discovered once we have a large-scale, a quantum data center that you can just play around with and discover things as well.
So fast forward from 2016, 2017 to today, Xanadu has raised over $250 million US in financing. The company has a valuation of over $1 billion and is a unicorn. And you're still here in Toronto, and you're Toronto-based. Can you talk a little bit about that at a time when a lot of companies that start out in Canada, and as they grow and scale, they actually leave?
Well, I wonder how many people would leave Toronto if they thought you could do it here. A lot of the stories I hear is that you need to go there because of the market, you need to go there because of funding. What people perhaps don't know is that there's enough funding in Canada already. Now, unlocking that funding is a challenge. Um, but it does exist, which is encouraging. And I think investors, entrepreneurs just need more and more stories of examples like Xanadu that actually are showing you can do this. Our seed in Series A was led by OMERS, and then our last round of 100 million was led by Georgian. And Georgian have been fantastic along with OMERS, but they don't normally invest in deep tech and hardware sort of stuff, crazy stuff like this. But we formed a relationship with them. They love the team, and they put a little bit of money in before the 100 million lead. And so you can also change people's minds as well, even if they don't do it. So I think just sticking to your guns, we'll never move our headquarters to the US. It came about because I just moved to Toronto for a postdoc at U of T, and just fell in love with Toronto and wanted to stay. So that's kind of the driving force. But since Xanadu was started in 2016, there's been far more investment capital, many more startups. VCs have started, and the government support has been tremendous, and a lot of incubators as well, and a lot of great support from people such as OCI as well has been very, very helpful.
So the race for quantum supremacy is fierce, and with competitors like the major players, Google and IBM, making bold claims, how does Xanadu plan to stand out and stay ahead? It's a bit of a kind of a David and a Goliath narrative.
We get that. That's a good question. We get asked that a lot, and I would say success here is really dictated by success in the hardware. So you can build a quantum computer out of many different ways. We're using photons or light, so think of, say, lasers and fiber optics. And Google and IBM and others are using a different, say, electronic version of building a quantum computer, very different from ours. So that is really the fundamental way that we can compete, is they're doing a different version, and we're doing our version, and we all think we have the best approach. But the reality is there's a lot of pros and cons of every approach. But photonics definitely has some really key benefits to it. I would also say that even if there's a team at Google working on quantum computing, which there is, and they're doing great work, if you look at the size of it, we have 210 people. I think they have around about the same. So the amount of people is fairly equivalent. Then someone would say, well, they're Google, they have an unlimited amount of money. Well, they do have a lot of money, but it doesn't mean they're going to put it all on quantum computing. And when you're at a large company like Alphabet, you do need to compete with other things, like there's DeepMind, there's electrical self-driving vehicles, and many different endeavors there. They all have to compete for money. So it's like you have to raise money as well, like we do externally. So I don't see a huge advantage from that point of view, and their approach, if they were doing photonics, I'd be a bit more concerned. But having said that, I think there's room for more than one winner. And there's also the aspect of having sovereign technology and protecting your supply chain as well. So hopefully we have Canada behind us as well, and I think that's another huge benefit.
Let's switch gears a little bit and touch a little bit on some of the anxiety that exists around quantum computing, specifically around ethical concerns. So how do you address fears that quantum computing could exacerbate issues like cybersecurity threats or create increasing economic inequality?
Well, the cybersecurity one is interesting because that's how quantum computing was put on the map. Theoretically, it was shown in 1994 that if you could build this large quantum computer, you could actually hack the internet, which was only just beginning commercially back then. So on one hand, everyone knows about it. All the governments around the world know about it. So it's essentially in their hands now what they want to do. And then there's a lot of startups working on not quantum computing, but quantum security, which is providing replacement encryption and codes that a quantum computer won't be able to actually hack. The other thing is this quantum data center that we'll build, it'll solve the initial use cases will be quantum chemistry, as I mentioned, batteries and so forth. But the decade after, maybe 2035, unless of course there's a big breakthrough, it's only then the computers, if everything goes well, will be of a size that can actually hack the internet. So that means we're still, if that's true, over 10 years away. So there's enough time for people to act. But having said that, it is a challenge. You talk with banks, and a lot of time they're using legacy security equipment. It's very hard to sort of get them to convert over unless there's a, because it takes money. And it's like money that you weren't intending to spend that you have to spend. So that's a challenge. And also, on an argument to act now, is that there's data that needs to be secured for decades. So every government in the world is actually kind of downloading information now, but you can't decrypt it. So things like patents, medical records, certain banking information and so forth, all these things need to be kept secure for decades. So even if it is 10 years away, you can download and decrypt later sort of strategy now. So that is of a concern. But people are aware of it. It's up to entrepreneurs and the government to fix the problem.
So looking ahead, what are your predictions for the future of quantum computing? Let's say in the next 5 to 10 years, what do you think we will see?
Well, I'll go just for the first 5 years because it's changing very quickly. A lot of great results the last 6 months in quantum, so a lot could change even the next 2 years. I would say though that the next 5 years is really the emergence of a quantum data center. Hopefully by Xanadu and others. There's enough room for a few winners, and that's what our goal. Now, 5 to 10 years, just expanding the data centers throughout the world. Improving the size, improving the performance of them, and so forth, and then seeing more of a significant customer adoption as well. In things like chemistry and material design and others.
So in the last couple of minutes that we have, two questions. So innovation is really, really important for competitiveness, but especially the sector that you're in, it is critical. So how do you foster and maintain a culture of innovation at Xanadu?
I think we may have it a bit easier than others because when you hire people to work on quantum computing, the first hires that I mentioned first, 80 plus or so, PhDs in quantum physics. So someone that has a PhD is already self-motivated for the most part and very curious. So now we're giving them another place where they don't have to teach, don't have to worry about looking for a job at a university, and they can just you can release them to keep working on stuff. So that just comes naturally given the fact we're in quantum computing. I think, outside of that, we've been hiring a lot of engineers and software folks, and, we're competing with their talent with, non-quantum usual companies. And so they want to work on something meaningful and purposeful as well. So innovation comes automatically with quantum computing because you just have to keep innovating. You have to keep discovering and pushing the technology forward. It's not like the product is there and you're doing incremental improvements and maybe you get lazy or bored and just want to keep doing the status quo. We have to keep innovating or we won't, or we'll fail.
Last question. What message would you like to leave with the audience, not only about the future of quantum computing, but about entrepreneurship and the founder's journey?
Yeah, the founder side of things and entrepreneur in general is very, very challenging to do, and I think it's important to choose something, whatever product or service you want to build, that you actually feel you would buy that yourself and you just love it. I mentioned one other day that if you could guarantee me in 10 years I'd be a billionaire, but I had to sell plants like this. But you can guarantee it, and there's no doubt I'll be a billionaire. I just can't wake up every day and look at this, even in general. So I think, choose something that you want. You're trying to fill a gap in society. You're trying to sell something that hasn't been there. You want to get up every day. Not every day is easy. Most days are quite difficult, actually. But, the simple litmus test, would you rather be doing this than some other job as well? And sometimes it's hard to, I think really our minds are great for simulation. So you don't have to experience something to know something's been true. Otherwise, you'd be have to live multiple lifetimes. You can read books, you can ask for advice and learn things. But a simple thing is just sort of simulate when you go to bed tonight. You're on your bed, pretend it's your deathbed, and you've got 2 minutes left. It's all going to happen to us. The question of when. But do that and think, am I happy with what I'm doing? And there are other options too. I believe that you can, you don't have to quit your job or anything, but maybe at nighttime you spend half an hour looking at a new topic, watching a new video on YouTube, and then slowly edge towards something in order to change your life.
Thank you for those inspiring words and for your insights. We look forward to hearing many more great things as Xanadu continues to scale and grow. Please join me in thanking Christian.
Thank you.